Okay, sorry about getting cut off there for the previous video. So anyway, back to this problem. We're asked that the solutions are mixed with the expected concentration of nitrate ions. And you can see, let's start off we start off with 4 moles of each. Because it's a 2-to-1 molar ratio, what that means is that if we have 4 moles of both potassium hydroxide and lead nitrate, potassium hydroxide is going to run up first since we need double the amount of it than we do lead nitrate. All right. So this is what it looks like when on our reactant side, but on our product side, we're going to form some solids. So I drew that solid at the bottom here. This is our lead hydroxide. Remember, this solid line is to denote some solid sinking at the bottom. That's where our lead hydroxide is going to be. For our lead nitrate and our potassium nitrate, that's still going to be floating in the solution. And remember, that's the excess lead. So we're going to have some Pb2 plus left over, but mostly we're going to have potassium nitrate in there. And so you'll notice that the number of nitrate ions, since nitrate is an aqueous on both sides, aqueous compounds on both sides, that the nitrate that we start off with is the nitrate we end up with, the same number. So essentially what that means is if I can just figure out the moles of nitrate in lead nitrate that I used, then that's going to tell me the moles of nitrate that I have left over. And so this is the information that's relevant to me, the information for lead nitrate, and I want to go from the volume and molarity of lead nitrate to the mass of, sorry, not mass of lead nitrate, but actually the concentration of NO3 minus. So let me go ahead and change that. Okay, so what does that look like? I'm going from the molarity and volume of lead nitrate to the concentration of nitrate. So this is sort of the molarity volume thing. And I can go ahead and use the M1V1 equals M2V2 shortcut. Since I'm going from lead nitrate to nitrate, which are not the exact same things, I will need to use my molar ratios, which are my M's. So whenever we're using M1V1, we have to identify substance 1 and substance 2. Let's say I say my substance 1 is lead nitrate. I have its molarity, I have its volume. And according to the balanced chemical equation, according to the chemical equation, if I have 1 mole of this, then I would have 2 of the nitrates. So right now I'm looking for lead nitrate. I'm just going to say that that's 1 because that's the entire molecule. Substance 2 is my nitrate, which comes from the lead nitrate. The molarity is what I'm trying to figure out. The volume, we're going to get by adding the volumes of the 2 solutions we mixed together, 350 milliliters of one solution and 400 of the other, and that's how we get the volume. And then the moles, 2, this number is going to come from the fact that according to the chemical formula, for 1 mole of lead nitrate, there are 2 moles of nitrate, and I know that by this subscript outside of the parentheses. So this subscript outside the parentheses tells me that we have 2 moles of nitrate for 1 mole of lead, so that value is going to be 2. Go ahead and plug that into my M1V1. This is what sort of my math looks like, and this is my concentration. And that should be 2.3 molar, by the way, not liter. Take a moment to sort of look over this work if you have questions about how I did anything. I'm going to explain on the next slide basically the volume situation. We're going to go into CFU4, which is a stoichiometry, next stoichiometry problem. So in this problem, a student adds 30 milliliters of a 2.5 molar sodium hydroxide to neutralize 50 milliliters of a 2.0 molar HCl solution, and I have 3 separate questions. We're going to write the dynamic equation. We want to know if the student was able to completely neutralize the acid, essentially meaning, did we add enough of the sodium hydroxide to neutralize the acid that we have? And determine the pH of the resulting solution, and also see if that makes sense given what we know in part B. So what do I mean by that? If we added enough of the base to neutralize the acid, then it should have a neutral pH. If we did not add enough, then there should be more acid than base, and so the pH should be acidic. If we added too much, then that means we have more base than acid, so the pH should be basic. So that's what I'm meaning there. All right, pause the video now. When you press play again, the answer will be revealed. Let's start off with the dynamic equation. This is the process from molecular to complete ionic. and then we can cross out things that are aqueous on both sides, and this gives us the net ionic. For acid and bases, you need to get to the point where you no longer need to do all of this work and just know that the acid and base net ionic equation looks the same. H plus OH minus goes to water. For part B, we're asked if the student was able to completely neutralize the acid and explain. So for that, we need to figure out, did we add enough? So we have I'm going to pause this for one quick second. Okay, so according to the information in the problem, we are adding 30 milliliters of 2.5 molar NaOH to 50 milliliters of HCl. So here's what this would sort of look like. NaOH is not blue. This is just so we can see what's happening. And my question is, did I add enough base to neutralize the acid? That's what I want to know. Did I add enough of this to neutralize that? All right, so what information am I given? I'm given the volume of HCl and its concentration. I'm giving the volume of NaOH and its concentration. And I need to know, well, how much NaOH do I need for this HCl? And then I can go ahead and just check to see if I have enough. So I could ask myself, well, how many milliliters? All right, the easiest thing to think about is that we're not going to change the concentration, but just the amount we pour in, its volume that we pour in. So how many milliliters of NaOH do I need to neutralize 50 milliliters of a 2.0 molar HCl solution? Okay, so that means that I'm going from molarity and volume to molarity and volume. So of course, I'm going to use that shortcut in 1v1 shortcut. All right, so now that I know that, let's go ahead and set things up. I always choose my substance 1 and substance 2 and just list the stuff for it. So for substance 1, it's going to be HCl because that's sort of the information I have there for it. And for substance 2, it's going to be NaOH. So I'm trying to figure out the volume of a 2.5 molar NaOH solution. The molar ratios are going to come from, these numbers here come from the molar ratios of HCl and NaOH in the balanced chemical equation. So those are the coefficients. I plug it in. I figure that I need 40 milliliters of NaOH. Well, to neutralize, what that means is to neutralize 50 milliliters of a 2.0 molar HCl solution, I need 40 milliliters of NaOH. I look and see that, I only added 30 milliliters. So I'm like 10 milliliters short there. So that means that I did not completely neutralize the HCl. I still need to add more NaOH to neutralize it. Okay, the last one is, what is the pH of the resulting solution, and does the pH make sense given your answer to part B? So before we go into sort of what that looks like, I just want to start by looking at sort of this particle diagram here. Remember that in acid-base reaction, when we mix them together, we form a neutral solution. And why is that? That's because the acidic proton and the OH minus, they react together to form water. And in our example, NaOH is our limiting reactant, meaning we don't have enough NaOHs to neutralize all the HCl. And we can tell that from just looking at the OH minuses and H pluses. We have 1, 2, 3, 4 OH minuses, but 1, 2, 3, 4, 5, 6 H pluses. Well, that means that, hey, not all of the H pluses are going to hook up with an OH minus. A couple of them are going to be left out. And so the two we have, in this case, we would have 2 remaining over, and the rest of them are going to form this neutral H2O solution. So how does that help us with the pH? We can use what's left over to figure out if we know the concentration of H plus left over, we can figure out our pH from there, because remember, pH is equal to the negative log of concentration of H plus. So essentially what we want to know is what's left over. To figure out the concentration of H plus remaining in the solution, there's some things that we need to know. We need to know the moles of HCl that we used in the first place. So what is the moles of H2L that we started off with in this reaction? And we'll use the information of 50 milliliters and 2.0 molar of HCl to find that mole. Once we know the amount we use, we're going to figure out the amount that's remaining. So we'll take our initial amount, which will come from the 50 milliliters and the 2.0 molar HCl, subtract the moles that we use. And the moles that we use, by the way, I'm sorry about making this confusing, is that the moles that we use are actually going to come from the amount we use to react with the NaOH. And then what's remaining is what we'll then use to get the moles of HCl, and we'll use the moles of HCl to find the moles of H plus, and then plug that into the pH equation. So let's start with finding out the moles of HCl that we need. We use. We need to ask ourselves how many moles of HCl are needed to react with 30 milliliters of 2.5 molar NaOH. All right, so this is what our math would look like. So according to this, we would need 0.075 moles of HCl to react with this amount of NaOH. Once we know the moles of HCl that we needed, what we're going to take is the initial moles of HCl and subtract it from the moles that we used. So our initial moles, we just take the molarity, multiply it by its volume in liters, and that's going to give us the moles. So I just take these two numbers, 50 milliliters and 2.0 molar. I did convert the 50 milliliters to liters and multiply it by the molarity, and that gives me the moles of HCl that we started off with, our initial amount. And I'm going to subtract from that the moles of HCl that we used. And again, I found that out by determining how much moles I need to react with the amount of NaOH I have. And that you saw previously was 0.075. That means that I have left over 0.025 moles of HCl. Now, since it's a 1-to-1 molar ratio, the moles of HCl is going to equal to the moles of H+. So now I want to go from moles of HCl to moles of, to concentration of H+. And this is sort of the process of what it looks like. So when I map out my work, it looks like this. I have, I go from moles of HCl to moles of H+. It's a 1-to-1, that's pretty simple. And then once I have the moles of H+, I get the molarity. I want to divide it by its volume in liters. Well, what is the volume in liters? And that's where we need to be careful. So what do I need to know is the volume of the entire solution after I mix everything together. And remember that we start off with 50 milliliters of HCl and 30 milliliters of NaOH. So when we mix those together, the total volume of our solution is going to be 80 milliliters or 0.08 liters. So that means that what I need to do is, for my volume, I need to plug in 0.08 liters. And that's going to be 0.31 molar. So that means the concentration of H+ is 0.31 molar. To get the pH of the solution, what I need to do is just take the negative log of the concentration of H+, which I determine is 0.31 molar, and that's going to be a pH of 0.5. All right, so now the question was, does this answer make sense? Yes, it makes sense, because remember, we ran out of NaOH, so we didn't have enough of that to neutralize all the HCl. That means that there's still some HCl left over. So my pH should be in the acidic zone, and it is. It's less than 7. All right, let's move on to final tips. You want to make sure that you analyze, which is reading, identify finds and givens, and write in chemical reactions. When you're doing the problem. You also want to make sure you plan by mapping it out. So you're mapping it out and doing dimensional analysis, or using this M1V1 equals M2V2 shortcut. Make sure to cancel out units when doing dimensional analysis. That will make sure that your work is correct, and check to make sure your answer makes sense. All right, that's it for this video. Have a quality